Hello friends, in the last class we are discussing about SEJ gap adjustment during welding. Alright, so how gap was adjusted during welding. So now question is why gap adjustment is required. Okay, so why gap adjustment is required. So initially while fixing SEJ we think that the temperature at site was TD, and accordingly based on TD temperature the position of tongue rail was fixed, right? So say assume that this is our SEJ, so from here to here you have SEJ, right? And joints of SEJ was temporarily fixed using fish plates. So this is one fish plate, 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 right? Now so and we have now this track structure was not continuous, right? So you have joints here, right? And when we do welding, uh, we should ensure that whatever position of tongue rail is there, that should be correct, right? So now question is whether how you know that it is correct or not. See, at a TD the tongue rail should be exactly coinciding with mean position of this, right, center line. And when temperature is more than TD or when temperature is less than TD, the position will be different, right? So see at TD, so at TD this is the position of tongue rail, right? And when temperature is more than TD, when temperature is more than TD, there was expansion. As a result, gap should become lesser. Its rail should move from mean position towards stock rail. But at site it may be towards the stock rail, or it may be here also. It may be here. Alright? Because see, our track was not continuous. Our track was not continuous. You have joints like this. So whatever movement has happened, some movement will get adjusted at the gaps here, and remaining movement will be seen in the tongue rail, right? So whatever position of tongue rail is there, that may not be correct. Okay, so when temperature is more than TD, it may move excess towards stock rail, or it may move very less towards stock rail, so that might be there. Or when temperature is less than TD, it may move more away from the stock rail or very less away from the stock rail. So if you don't adjust this, then during service actual condition, okay, the gap may not be sufficient or gap may be excess, right? So you have to adjust the position of tongue rail. Now question is how to adjust the position of tongue rail, right? So see here, if you wherever okay, so when you are doing welding, if temperature is TD and position of tongue rail is exactly like this, exactly at mean position, then you can directly weld the SEJ. You can directly weld the SEJ, right? And if position was not correct, then you need to adjust, right? So now question is how to do adjustment of SEJ gap. So for that you should have a concept called reference pillar. So what is this reference pillar? So these are the rail pegs fixed outside SEJ, which helps to measure gap in SEJ at different temperature. Means what? So let us say this is your SEJ and this is the gap in SEJ. Now what you do, you will fix some rail pegs, one on LS side and RS side, and you will mark a reference line like this. And based on this, so with respect to this reference line, you will measure the position of tongue rail. So this is called reference pillar. So now you can come to this picture. Now question is how to adjust, right? Okay, so this is our reference pillar. So and this is the reference mark. What is the location? So it was at a distance of 20 mm from mean position. So this is our center line. So from here at 20 mm towards stock rail side, we'll fix this reference line. Okay, we fix this reference line. Now once we fixed this reference line, okay, so once we fixed this reference line, now we will understand. Okay, let us say this is our sleeper and this is the center line. Okay, once we know TD and once we know temperature at site, okay, once we know TD and once we know temperature at site, code suggest what should be the location of tongue rail, what should be the location of tongue rail. So you can see this table. So this I have taken from here. So IRPWM para number 338 annexer 3/9. So from there I have taken this table. See here, so for a given rail 60 kg or 52 kg, sleeper density 1660 or 1540, and longitudinal rail, okay, longitudinal ballast resistance for this condition and temperature, you can note down, you can get what should be the location of tongue rail. So zone also, for each zone you have this data. So I am taking for example zone 2, and temperature was at TD plus 10 at site, temperature was TD plus 10. So for this temperature, okay, at TD plus 10, at TD plus 10, the position of tongue rail from our reference line, is how much? 17 to 21. In this range it should be there. So like this, so I have made one table. See, at a TD plus 10, tongue rail should be at 17 to 21, and if it is exactly in this location, then you need not adjust. And if it is outside this, let us say 30, then you have to adjust such that you bring it to this range. And similarly, see, TD minus 10, it should be 20 to 28. And average value, generally what we are doing, we are taking average value, and whatever average you have taken, it was in this range, right? If you take 24 was in between 20 to 28, so you are adjusting tongue rail position to 24 mm. So how we are doing, let us see here. Okay, so this is our reference line. So this is our reference line. Now let us take TD plus 10 we have taken. What should be the position? 19 mm from here. So our tongue rail should be 19 mm from here, right? 19 mm. What is the initial position? You check it. So what you have to do, I will show here. So I am writing here. So this is our, let us say this is our reference line. Okay, so let us say this is the position of tongue rail. Tongue rail was here, okay, which is at a distance of 30 mm. This is the present location of tongue rail, and where we want at this temperature 19 mm. So I want somewhere here 19 mm. Alright, so what I have to do, you have to push the tongue rail toward this direction and make here. So you should adjust like this. Initially it is like this, so you have to push this tongue rail towards this direction, so that now it becomes 19 mm. Similarly for any other conditions. Okay, so if at TD you are doing welding and bringing continuity in the track, because you have joints here, you want to remove this. Okay, so when you are doing welding, temperature was TD and position of tongue rail was same as per standard. Okay, then you directly do welding. When it was different, based on temperature, if it was different, then you have to adjust it. How we have to adjust? Just now I have told. Okay, so based on temperature, if at TD minus 5 you are welding, and at that time if position of tongue rail from reference point was 22.5 mm, okay, if it is other thing beyond this range, then you have to adjust it. Okay, alright, so that's how we will adjust the position of tongue rail based on temperature. So once we know position of tongue rail, we will adjust it. Okay, and we will start doing welding, and once we complete welding, we will allow the traffic, we will remove all caution orders and we'll allow the traffic. So after our welding, we allow traffic with a normal speed, and after a few days of its service, we want to understand whether gap was sufficient or not. So whatever gap we have provided, whether it is okay or not, whether it is excess, whether it is less, whether it is more, that we want to understand by inspection. So how to do inspection? So let us understand, right? So how to do inspection, let us understand. So what we will do, so we have our reference post, reference pillar, which is at 20 mm from center line. This is fixed, right? So what is this reference pillar? You can see these are rail pegs, okay, fixed along the line 20 mm from center line toward the stock rail side, towards stock rail, and it was at a distance of 20 mm from center, and all kinds of gaps of tongue rail was measured with respect to this reference line only, right? So now what we will do, from reference post we will measure what is the distance of tongue rail tip. Okay, so we will note down what is the temperature at site, what is the temperature at site when we record this measurement. So once we know temperature, and once we know what is the distance of tongue rail from reference post, then we will recheck with code, right? Annexer 3 bar 9. So we will recheck here. Suppose whatever temperature we got was TD plus 10 or TD plus 20, let us say. So at this temperature, what is should be the gap? 17 mm. From reference post, the location of tongue rail should be how much? 17 mm. Suppose you get 17 mm, okay. If you get more than this or less than this, then you should check what is the problem with, whether it is with SEJ or whether it is with LWR. You have to verify it. Okay. So similar way, suppose you are measuring temperature was TD minus 20. Let us say your measuring temperature was TD minus 20 and you got around 18 mm location of tongue rail, and what code suggests 23 to 30, right? So it was out. So now it means there is problem with the tongue rail. And also there was one more suggestion about this, right? So this is para number 338 2B IRPWM. This also I have taken from there. The gap between reference mark and tongue rail tip, which is attached to the LWR at various temperature, shall not differ by more than plus or minus 10 mm from theoretical range. Okay, from the table value, see you have table value this one, from this plus or minus 10 it can vary, beyond this it is not okay. So that's what it is suggesting. Okay. Okay friends, I hope today whatever I want to discuss, it was clear, right? So at TD and welding also at TD, you need not adjust, just check the location of tongue rail and weld it. Okay, if you are welding other than TD, greater than TD or less than TD, then you have to adjust the tongue rail position, and if it is within the range as per code, then okay, otherwise you need not adjust. That's what we have learnt. Okay friends, thank you so much for watching.